Today we're going to talk about one more type of way that we can represent data and show it in a graph sort of form, but also get some details related to some pieces of that graph that we call the 5-number summary. So we did a dot plot, histogram, and this one is called a box plot. It's related to the 5-number summary. So in order to do a box plot, and you're going to see an example of a box plot right here, we're going to need to get some pieces of information from a data list. So one of the things that we need is the lowest value called the minimum. Okay, so the minimum is the lowest data value, the smallest data value. The one with the smallest number itself. All right, then we have something called the lower quartile. This is abbreviated as Q1, and we also know that it is the 25th percentile. We don't hear that word percentile a lot, but we hear it sometimes in the doctor's office and sometimes with standardized tests. And basically that means 25% of the data is below it. Okay, so 1/4 of the numbers, when we're talking about quartiles, by the way, we're talking about separating our data into fourths, because a quarter is 1/4 of a dollar, right? Quart means 1/4, quarter. So lower quartile. And then we have the median, which should be familiar to you. This is sometimes called Q2, the second quartile. And we know that this is the middle number, which is also the 50th percentile. So what that literally means is half of the numbers are below it. So that's like the 2/4 of our data gives us up to a half. So 2/4 would be like a half a dollar. So, right? So the median is halfway. Then we have something called the upper quartile. And the upper quartile is abbreviated Q3, and that is going to be our 75th percentile, which means that 75% of the numbers are below it. So if you're in the Q3, the 75th percentile, that means 3/4 of the numbers, 75% of the numbers are below it. And then we have the maximum, and that is going to be our highest number, our biggest number on the data. So this is our 5-number summary then. Notice there's 5 pieces to it: the minimum, the lower quartile, the median, the upper quartile, and the maximum. And in our box plot, each one of these pieces are going to be represented. So right here, notice that we have the lowest number right here is represented by this line. That's the minimum. So in this case, the minimum would have been 2. The next little vertical line here that's the beginning of the box is our Q1 number. So that's our 25th percentile number. So that means that if we had a list of numbers here, 1/4 of them, 25% of them would be below 4, would be under 4. We can't see all our individual data points here, but we know that would be below 4. Okay, this next line is where our median is. So that's the median, or Q2. And then we have our next line right here. So by the way, the median would be a little bit above 4 here. It's a little bit hard to tell if that's exactly 4.5 or not. Then we have the next little vertical line that makes up the end of our box here. And that is going to be our upper quartile number, Q3. So that's roughly at about 6.5 here. And so that would be 75% of the numbers would be below that 6.5. And then we have the maximum right here. So that's our biggest number in our list. If we were able to see all our numbers, that would be the biggest number, which would be 9. So that's the graph that represents our different quartiles. So basically it breaks it up into fourths. So minimum to Q1 is 1/4 of the numbers. Q1 to the median is the next 1/4 of the numbers. The median to Q3 is our third 1/4. and our Q3 to the maximum is our fourth. So there's like 4 parts that it breaks it up into, which are our quartiles or percentiles. So this is going to give us a little bit more information about the data. So we're going to go back to our data with the tomato plants. Recall that yesterday we were using this data and making a dot plot and a histogram related to the distribution of this data, how it's like spread out and seen. So we're going to look here at finding the 5-number summary. So we're just going to go through the list of numbers here and take it piece by piece. So number 1 says, using the same data as the previous activity for tomato plants, find the median and add it to the table. What does the median represent for this data? So in this case, we know if we count up all of our numbers here, there are 30 total numbers. 1, 2, 3, 4, all the way up. There's 30 numbers. There's 15 in the top row and there's 15 in the second row. And the great thing is they have already been ordered from least to greatest. That's going to be important. You have to put your numbers in order from least to greatest. So that's been done for us, so that'll make this a little bit easier. And if it wasn't done for you, you would have to do that. You would have to list them out from least to greatest. All right. So since there are 30 numbers in our data set, 30 numbers in data, so 30 tomato plants, in other words, the median is going to be the average of the middle 2 numbers, because if there's an even amount of numbers, there's not going to be an exact middle number that's in the list. So the average of the middle 2 is going to be the median of our list here. So that would be then the 15th and 16th number here. The 70 and then the first 72 would be the 15th and 16th number. Those are our middle 2 numbers in this data list. So the average of 70 and 72, in other words, halfway between 70 and 72, so 70 plus 72 divided by 2, that's 142 divided by 2, which is 71. So the median of the data list here is going to be 71. All right. So that's how many days, that's the median number of days it takes to produce tomatoes. So half of the tomatoes, 50% of them, half the tomatoes, take less than 71 days to become fruit. I didn't word that quite like I wanted to originally, but essentially it's how long it takes before we get a tomato. How long does it take a tomato plant before we get a tomato? So half of the plants took less than 71 days to become a tomato. All right, so we found the median. You guys have done that before, figured out where a median is. So the second thing is to find the median of the least 15 values to split the data into the first and second quarters. This value is called the first quartile. Add this value to the table under Q1. What does the value mean in this situation? All right, so we talked about that. So what we're going to do is we're going to take the first half of the numbers, okay? Not including the median. Remember, we figured out the median was 71. It's because it's between the 70 and the 72. So we take the first half of the numbers and we find the median of that first half. So there are 15 numbers in the first half of the data. So if we think about that, if there's 15 numbers, that's an odd number of numbers, which means we're going to have an exact middle. So if there's 15 numbers, the 8th number will be our exact middle. 1, 2, 3, 4, 5, 6, 7, 8. Here's the exact middle of that first half. Here's the median of the first half. So 62 is the, I'm going to say median of the first half. which is our Q1 value. Okay, so 62 is our Q1 value. And remember, Q1 was our lower quartile, which means 25% of the data was below it. So 25% of plants, of the tomato plants, take less than 62 days to produce a tomato. Okay, so that's that first fourth of the data is our 25th percentile, which means 25% of the data is below it. So since 62 is our first quartile, 25% is below 62. All right, we're going to do that same thing for the upper quartile. We're going to look at that second half, not including the median. Again, in this case, the median was over here on the side because it was between the middle two numbers. And we're going to do the median of the second half. So the median of that second half is going to be since there's 15 numbers in that second half, just like there was in the first half, the median of that second half is going to be the eighth number, 4, 5, 6, 7, 8 of that second half, because halfway for the 15 numbers is the eighth number. That's the exact middle. So 78 is the median of the second half, which is the Q3 value, the upper quartile. So 78 is the upper quartile. And that means, since it's the upper quartile, 75%, it's the 75th percentile. Upper quartile is the 75th percentile. So 75% of plants take less than 78 days to produce a tomato. So 75% of the plants are below 78. So take less than 78 days. All right. Those are the harder three to figure out. Luckily, the last two are very simple to figure out because that's the minimum and the maximum. The minimum is simply the lowest number on our list, so 47, and the maximum is the highest number on our list, so 90. So 47 and 90 are going to be the minimum and the maximum. So maybe we can put over here. So 47 is the minimum, and 90 is the maximum. All right, so now we have all the information that we need in order to make the box plot, which is essentially the way we represent the 5-number summary. So all we have to do is create a scale. Now, luckily, the scale has been done for us, the time and days for tomato plants to produce a tomato. The scale has to be in equal step sizes. Whatever your step size is, you have to be consistent. In this case, it goes by 5s. So now we're just going to take our 5-number summary and we're going to put it into our box plot. So the minimum is 47. So estimate about where 47 is and put a little line above that, 47. So that's our minimum. Right? Our Q1 value was 62. So estimate about where that 25th percentile is. 62 is about right there. All right, so we make a little line up to the 62, to that lower quartile. The median was 71. So we'll put another little line, 71. I'm going to estimate about where that is. Now that's the beginning of our box. All right. The upper quartile was 78. So put another little line above about where 78 is, actually probably a little bit further over than that. So 78, that's the second part of our box. That's the end of our box. 78's the upper quartile, is the end of our box. And then we had a maximum of 90. So put a little line above 90 and you do your, we call whisker, up to 90. So this is our minimum amount. This is our Q1. This is our Q2, also known as the median. This is our Q3, also called the upper quartile, and this is our maximum. That's our 5-number summary. Now we're going to analyze our box plots a little bit in coming days, but for right now, let's just think about these two questions then. What can we see? Can we see individual data values in a box plot? And unlike a number or a dot plot, we can't really see the individual values. We can see what the minimum is and the maximum, but everything else is kind of scattered in between, so we don't know all of the individual values. So no, we know the min and max, and we know the median, but the median may or may not be one of the numbers in our data set here. Notice that 71 was our median, but that was not one of the numbers in our set. It was the average of the middle two. So no, we know the min and the max. Oops, almost lost it there.